So a little bit more of terminology that still means the same thing as we've seen. So we have calculated the volume of a cuboid, and then we found that the area of the base, and we found the area of the base, that area that we found is also referred to as a cross-sectional area. Cross-sectional area meaning if you take a three-dimensional object that has the same uh, sides, such as the rectangle or square, even if you were to elongate it as long as you want, depending on where you slice it and calculate the area there, it will be the same as if you slice it further down the line. This is the importance of parallel lines. Parallel lines depend, it doesn't matter where you measure them, they should measure the same distance apart. So it's referred to as a cross-sectional area. Cross-sectional meaning when you cut it across at different points, it will give you the same measurement. Hence, the cross-sectional area is a shape that is repeated throughout the volume. So we then calculated how many layers of cross-sectional areas by fitting the cubes into the cuboid. Because it is a cross-sectional area, it will be the same throughout. That's why you use, after you calculate the area of the base, whatever you get, you just multiply it by height, meaning you just add the same thing on top of each other until you complete the cuboid. So this again gives us formulas for, we can use that as an approach to calculating a volume for other three-dimensional objects by simply knowing that first we will need to figure out what is the base or cross-sectional area. So you have a three-dimensional object, you pick which side is the base, and then you calculate the area of that base. That base, it is the cross-sectional area because it should be the same as you cut it across as you measure it at different parts from the first one that you picked as the base. If it doesn't, then it's not a cross-sectional area. We will see, I'll explain that just now. So volume of any three-dimensional object, have to calculate the cross-sectional area first, then whatever you get, you multiply by height. So for a cylinder such as this, you will pick the bottom as the base or as the cross-sectional area, because this blue, highlighted in blue, it will be the same if you keep moving it up until the top. For this one, you cannot pick this as base. Why? Because it's not a cross-sectional area, because if you keep increasing it, the triangle becomes smaller at the top. But if you pick this one, it will be a cross-sectional area. It should be the same throughout because it will go in that direction. Well, this one, if you had picked that as the base, going up in this direction, it's not the same throughout. So cross-sectional area, it has to be the same throughout. So be careful when you pick what side is the base or the cross-sectional area. Similarly here, you can't pick this, for instance, as your base or as your cross-sectional area, because if you were to increase this into the object itself, you see it's going up further away from each other there, so it's not the same. But if you pick this one and then you keep slotting these layers along this way, then it will be the same throughout. That is the consistency and definition of cross-sectional area. Similarly here, you will pick this side. If it goes that way, it will be a cross-sectional area. And this is an example of composite figure that we also saw in the previous definition. And then the way to do this, it would mean you have to calculate the area 1 and area 2 as the area of this base. Only then you will calculate, you multiply by the height to get volume. So for the cylinder with the diameter of 4 centimeters and height of 6 centimeters, you will first calculate the base or the cross-sectional area. And we know from the previous modules that the circle, we had the formula for calculating the area of a circle and circumference and all that, and we know now terminology is about radiuses and diameters. So if you are given a diameter, you can figure out easily what a radius is, which is half the diameter. In this case it will be 2. Then the volume of the cylinder will be the cross-sectional area of what you had picked as the base multiplied by height. And then because the base is a circle, the area of a circle, we know the formula from the previous module is pi multiplied by radius squared. And then pi, we know it's 3.14, or in a fraction format to be 22 over 7. So it's much easier in a decimal format as 3.14 multiplied by, we know now area is 2, so it's 2 squared, which is 2 multiplied by 2. That would be the area of the entire circle, which is a cross section of the cylinder. You get 12.56 centimeters squared. Then to calculate the volume, you simply multiply it by height. Or as we've seen that the measurement of a volume is calculated using a centimeter cubed. So you can say per every centimeter of the height, I will slot this areas, because we said it's a cross-sectional area, until we fill up the cylinder, and then how many per centimeter, as we know, can you slot in there. And that means in a formula format, it will be the area of the base, or the cross-sectional area, multiplied by height. We know height is 6. We just calculated the area of the base. Then your answer will be in a cubic centimeter. Then overall, the formula for the calculating this the volume of a cylinder will be pi radius squared height multiplied by height. So when we go to triangular prisms, for this one, you know the area of a triangle from the previous module will be half base times height. How do you apply that here? So you calculate the cross-sectional area first of a triangle before you get to the formula, to the volume. Then what shape is the cross-section? We know it is the triangle, which is that one. And then calculating the area of it, half base times height. Half base times height from the previous module, and using the measurements we are given, that works out to 12.5 centimeters squared. Then keep slotting those triangles in this way 8 times. Then how many 12.56 are there? Or simply this area multiplied by 8 as the height. So the cross-sectional area by the height, okay, actually it's length here because height is going up. It is the length of, as we've seen, you can say height, or you can say 1 unit length, or 1 unit base, or 1 unit width. So that's why I keep mixing my words up with the height and length. They're all the same depending on how the shape is orientated. So in this case, because the orientation of the triangle is such that this is a length, you would say length, not height like that. Then volume works out to 100 centimeter cubed. So the formula for a triangular prism will be half base multiplied by height, which is first of the cross-sectional area, multiplied by L, which is the length in this case. Another exercise, try and calculate volumes for these objects or these figures, and then see what you get. Again, may or may not be in the worksheet.